텀 프로젝트 3 발표 시작하겠습니다. I'm gonna talk about the photolithography based on what I learned at the class. In the class material, we divide the photolithographic into 8 stages, but we will combine the two steps into one at the beginning and explain the rest. First, prepare the wafer. Photolithography process use wafer or other substrates in semiconductor manufacturing. This process cleans the wafer, removes the contamination, and prepares the surface for the desired resist coating. Second, apply photoresist. Coat the surface of the substrate with a sensitive optical material called a resist. This resist coating is used to record the desired pattern. The resist receives exposure only in the coated area and react to the exposed area. Next is soft bake. After resist coating, the substrate is lightly heated to remove the remaining solvent and dry the resist. This soft bake process stabilizes the resist and affects the chemical reaction after exposure. And expose. Use mask or masking to define the desired pattern and then expose the resist using UV exposure equipment or laser. Exposure serves to activate sensitive area of the resist. The exposed area changes the chemical or physical properties of the resist. And then post bake. After exposure, the resist is reheated to stabilize the chemical reaction and further strengthen the resist. This process is important to keep the pattern stable. And development. After expose the resist to the open liquid to remove the resist from the unexposed area. This reveals the patterns. The open liquid serves to dissolve the resist. Lastly, hard bake. After opening, reheat the resist to further stabilize it. This step is important for improving the durability of the resist and maintaining the desired pattern. This photolithography process is used as one of the key steps in semiconductor manufacturing and other micro-nanostructures. This allows precise fine patterns and layers to be formed, providing a high degree of control and repeatability. Now I will talk about the ASML EUV machine. There are 6 main devices in this machine. First, wafer handle. Robot arms move wafer inside and out the airlock. Second, wafer stage. Wafer stage adjusts the wafer in quarter nanometers for each process and inspect and checks 20,000 times per second. Third, optical column. The corresponding EUV system uses mirrors instead of lens to direct EUV light, and also reduces reticle pattern by 4-fold. Fourth, reticle. Reticle contains a chip pattern that should be copied to the wafer. In EUV, a reticle is a multi-layer reflector that uses interference to reflect light from a pattern. Fifth, vacuum chamber. The EUV system must be highly vacuumed in all processes because oxygen is also absorbed by the light. And for last is light source. In order to create the EUV light, the source shoots 2 separate laser pulses into the falling tin, which evaporates the tin and produces the lights. But one of the things we need to pay attention to is light source. This is because this light source is main technology of device. And I will explain how does this machine works. When molten tin is split into the form of 30 microns of water droplets, and the primary plasma hits the tin of the flattened. And when the molten tin is emitted with a stronger secondary plasma, a powerful light source is generated, and the light source generated at this time is ultraviolet or EUV. This source is used to obtain a light source required for the process and expose it to the wafer through a reflective photomask. After that, the device repeats it several times and develops its complete the hard bake. Now I'm gonna answer the question number 2. The answer to case B is similar to case A. When I choose to use the positive PR, it can give two advantages. First is effective for higher aspect ratio, and second is efficient for high quality works. The reason why negative PR is not suitable for this is due to the characteristic of the negative PR, and the resin polymer structure applied to the negative PR has the property of increasing the size of molecule structure. When the shape of the molecule structure changes by receiving the light, therefore, even if the negative PR reacts as much as desired, the volume itself changes as it reacts. So it is mainly used as positive PR with less volume change in the fine process. In the past, negative PR was used for fine patterns, but over time the size of the device became smaller and smaller, so positive PR that could be processed more fine than negative PR was used due to the limits that could be done by negative PR. Positive PR makes it easier to release bond between polymer molecules when it receives light energy, reducing bonding. So the parts where the bond weakened due to the exposure to light dissolves in the developer and disappears. The same pattern as the mask is formed because the exposed area is developed and an unexposed area pattern remains. And same as case A, I will choose the atomic layer etching as the same reason as case A. And the answer to case B is similar to case A. When I choose to use positive PR, it can give three advantages. First, highly trusted function. Second, it is efficient for micromanaging. Third, it's ideal for precise patterns. And there are some reasons. Line width fine pattern formation. Positive PR activates the exposed area and removes the rest to form the patterns. This is very effective when you want a fine line width or a fine process. Positive PR allows you to precisely control the size and spacing of line or spaces. High resolution. Positive PR is great at creating fine details. This is critical for the fabrication of fine patterns or semiconductor devices that require high resolution. Positive PR is a method of leaving an exposed area as a register. This allows you to control exactly what parts to etch and what parts to leave. The reason why negative PR is not suitable for this is due to the characteristic of the negative PR. And the resin polymer structure applied to the negative PR has the property of increasing the size of the molecule structure. When the shape of molecule structure changes by receiving light, therefore, even if the negative PR reacts as much as desired, the volume itself changes as it reacts. So it is mainly used as positive PR with less volume change in fine process. In the past, negative PR was used for fine patterns, but over time, the size of the device became smaller and smaller, so positive PR that could be processed more precise pattern than negative PR was used due to the limits that could be done by the negative PR. Positive PR makes it easier to release bond between the polymer molecules when it receives light energy, reducing bonding. So the parts where the bond weakens due to the exposure to light dissolve in the developer and disappears. The same pattern as the mask is formed because the exposed area is developed and unexposed area pattern remains. Positive PR is one of the standard methods in use in semiconductor and micro nanotechnology. Therefore, using positive PR may be better suited to standardized process and commonly used by many companies and labs. And same as case A, I will use the atomic layer etching as the same reason. Thank you for listening.